have, whether if you are a conservator or you're not a conservator, you will have it in your collection, whether you work in a museum, an archive, or on any cultural institution, actually. And if you are just a regular person you in home, you will have your roll film what you have in your analog camera, black and white. We say so. It's very important. What I say, it's very important to learn about what's inside your institution or what's inside in your house. Is it dangerous? It's not dangerous. We will learn about this today. Like it's like a brief about it's like a large science of course. So let's start with this man. This man is called George Eastman. George Eastman, from my point of view, is the one have invented one of the most greatest things in photography. Because what George Eastman in 1889 did, that he invented a new negative, which is light in weight and flexible. These two characteristics just help us to go further in the field of photography. Light in weight, that it helps us to carry 1,000 negative in you just in your handbag. You couldn't do that before that because the negatives were glass, and obviously you cannot hold the 1,000 negative in your handbag from glass, of course. So actually, it will helps to mass production for the industry. And the characteristics, another characteristics, which is flexibility. Flexibility is the key of what we call now movie industry or film industry, actually, because it allowed us to capture a moving image. So actually, that produces what we call now as movies. So without going into details, it's very important to understand the structure of any film that you have in your collection. From you can see, you have two kinds of films, all right? You have what we call black and white, what you call black and white, and you have a color film, right? So basically, we start with a plastic base. The plastic here, it could be nitrocellulose, cellulose nitrate, or cellulose acetate, or polyester, right? And you have a gelatin layer, right? You have the gelatin layer. The gelatin layer holds the image, which is contains which is form of silver in form of black and white, or in form of in color photography you have several layers of gelatin which has dyes. As you see, you have cyan, magenta, and yellow. Between the plastic base or the primary support base and the gelatin layer, you have a subbing layer. A subbing layer is normally is adhesive layer that enhance the adherence between the gelatin silver and the plastic base, actually. So it's a form of gelatin, and whether it's acetate or acetate or nitrate, right? And it's because it's tend to curl, they added, like in the bottom, they added an anti-curling gelatin layer. It's a gelatin layer. Its main purpose to prevent curling to the film, right? Inside the gelatin layer, here, they added something called anti-halation dyes. Anti-halation dyes is a blue dye. Its own purpose is to absorb the excess of light, right? So it will improve the sharpness of the image, right? So once we just learn about the layers of the film or the composition of the film, we will learn about some types of films. Uh, at your home, we call you might have a microfilms, you might have sheet films, you might have an X-ray, you might have an aerial, you might have a motion picture, you might have small gauge motion picture. Motion picture is movies, by the way. Small gauge motion picture is still the same. Magnetic sound track, I will explain everything in little bit details later, okay? And roll from the stair film. Let's start with the microfilm. Microfilm, as you can see here from this picture, it can be found at the sheet at 4 by 5 or 18.2 by 187 or in a film by 16 millimeters, right? Sheet films that you have in your collection, it can have in different sizes, not only 4 by 5 and 5 by 7, it can be different sizes. Just an example. All right, so the X-rays, X-ray when you were like in the millennium generation and you had an X-ray at your bones and something like that, the sheet itself, it's made of film. It's a film actually, and this film is whether the acetate, cellulose acetate, cellulose nitrate, or polyester, right? So we have also an aerial area when you take photos from the sky. And you have a motion picture, which are the film that comes with different sizes. You have small gauge motion pictures, the same sizes, but the smaller sizes, 8 millimeters, 9 millimeters, etc. As you can see. And the magnetic sound tag. The magnetic sound tag is they added and it recorded the sound in the movie, right? It had the same structure as the film, of course. Uh, Wolfer, do you have at your home? Actually, if you have an analog camera, black and white, you must, or a color photography before the digital era photography, you must have one of those roll films. So, right, we have also the still photo. Comes in different sizes, 60 millimeters, 62 millimeters, 2 by 2, 35 millimeters. All right, so let's ask ourselves a question here. Is it important to identify what kind of files that we have in our collection? Is it that important? Well, I'm telling you, if you answer is yes, I will explain to you why. Acetate, cellulose acetate and cellulose nitrates not only tend to deteriorate itself, but actually it releases gases. I will explain everything in details later. These gases, it will help deteriorate everything around them. Not only that, but cellulose nitrate, it has a characteristic of flammability. So it tends to have a fire. And once it get fire, uh, it will not be extinguished. So you might have a pump in your institution and you don't have power. To help you identify this, well, I will help you. I will give you some ways to identify it, but my advice is you should ask for an expert because it's very, very, very tricky to identify. Right. The first way to identify is something what we call notch code. What is notch code? Notch code is a cutting, what you can see here. It's a cutting in the edge of your film in different shapes, right? They use film manufacturer, they use this to differentiate between cellulose acetate and cellulose nitrate. And also it might be written, it's not visible here, but it's written here, nitrate codec notch code as to nitrate. If you just take a look at the bottom here, it's different. The notch code, the cutting is different from the one above. And you will see the word safety. Safety, when you see the word safety, definitely it is and cellulose acetate, just so you don't not think twice. It is acetate. Unfortunately, not all the manufacturer have followed the same, right? There is a guide for this notch code for Kodak, for example, and some other like manufacturer, but not all of them. Okay, so the second, only I didn't add this, but the second one is dating, right? I didn't add it because actually it's very, very, very large. Dating, as you can see, they invented the acetate nitrate in 1889. So actually, if you have something before around 1920, it's or 1910, it's definitely a cellulose nitrate, right? After that date, it might be cellulose nitrate, it might be cellulose acetate, actually, because some photographers they still have a stock when they invented the cellulose acetate because of the flammability of the nitrate. They still have a stock of the cellulose nitrate negatives. So it's still been in use. The third one is the stages of deterioration. You have six stages in each of cellulose nitrate and cellulose acetate. Uh, well, from you can hear, well, when you have it, it's sticky when in a third stage. I'm gonna explain the deterioration after, so I'm not gonna go into details now. But actually, if you have seen this color, this amber color of it's totally destroyed, it is or something that this color, that amber color, start to yellow amber color start to to appear. It is nitrate. It's like a 90% or 95%. It is acetate nitrate. Uh, well, when it's not deteriorated, it's very different, right? And when it's sticky also in a third stage here, it starts to be sticky. It is acetate nitrate. And actually don't take it because sometimes acetate cellulose, it's sticky also. Well, I've seen this. There is an explanation for this. For acetate cellulose or cellulose acetate, well, the most common thing when it's deteriorated, you have when it starts to curl, all right, it is cellulose acetate. And when you see these dots like the tree in fifth stage, it's called bacillus oxidation, right? We will explain this later. It's also acetate cellulose and overhead. So when you see this, the first, that like the last one, it's called delamination or channeling. When you see the delamination or the channeling, it is definitely an cellulose acetate, right? One other thing that we use is the polarization. Polarization, it's what we have seen. It's depends on we differentiate between acetate and nitrate cellulose and okay and polyester, right? So when we only use polarization, okay? Polyester, it shows colors like the bubbles when you see since you blew the bubbles in the air, it forms some red colors and some colors. If you see this colors, it's not acetate cellulose or acetate nitrate, or sorry, or cellulose nitrate, right? If you see this, it is polyester, so you are safe. Uh, One thing you use is a burn test. Okay, so the stage that the types or the ways of tests that I explained before, it is undestructive methods that you can use it with your object or your negative, and you still have the negative. From now on, we will explain the destructive methods. The first one is the burn test. When you burn an acetate nitrate, when I told you, remember when I told you it's very flammable? When you burn it, it's the fire, it will be very yellow. And it's like it burns too quickly because it's nature, actually. So when it burns too quickly, it is nitrate. The second one is diphenyl amine test. Right. Diphenyl amine test, we take, we prepare the solution from diphenyl amine. You dissolve it in a solution of the sulfuric acid, and be aware it has to be used with caution because 90% of the solution is sulfuric acid. How you know? It's we use this method to know it is cellulose nitrate or not. So cellulose nitrate, it turns blue. Cellulose acetate or polyester, it doesn't turn, it doesn't have any color. Sometimes you have to use one or more drops, right? It depends on the size of the space that you add this drops, right? The third one is a fluting test. The fluting test, we would use a solution of trichloroethylene. Trichloroethylene is toxic. So when you perform this solution, this test, it has to be in an open air. When you have this solution, okay, a nitrate, because of density, its density, right, it sank in the bottom if your, cup or whatever you use. Polyester would be in the middle, right? Acetate, it's because it's light density. It is floating in the top, right? So this is like a table of the destructive or non-destructive method that you can use to identify your collection. So dating is non-destructive, batch code is non-destructive. What stage of deterioration? It's already deteriorative, so it's non-destructive. Okay, polarization is non-destructive. Diphenyl amine, fluting, burn test. The three of them are very destructive to your negative. So my advice, do not go for those three tests before you go for the above four tests. All right, so we have learned how, like, step by step, we've learned how to identify our films in our collection. We will talk about deterioration and what happened in our, what kind of deterioration you have. Remember when I told you that you can use deterioration to identify your collection, identify your negative? Sure, we have to understand, we are conservator. We have to understand what happened, what causes this, why this happened in this type of negative. Okay, I will talk about some deterioration here. And of course, there are more, but we have limited time. We will start with the lamination. Okay. In in the basics, just to have it in your mind, cellulose acetate, cellulose nitrate, they form from a long polymer of cellulose, okay? And you have side groups of nitro and acetate, right? So when you have the first one is the delamination of the channeling. When you see this delamination or channeling in your on your negative, it's definitely an acetate cellulose negative. So what happened actually is that because of temperature, heat, okay, and moisture actually, and pollutants, the acid group, okay, the acetate group, okay, detach from the long polymer and forming from in the form of moisture is forming acetic acid. It has a vinegar, which we call a vinegar syndrome. Actually, this will attack the base, only the base, right? Shortening the long polymer of cellulose. It causes it to shrink. It's because of different the shrinkage between the base and the both sides. If you remember the both sides of gelatin, okay, it will create tension. The tension that causes some areas in weak areas, right, where it's not attached very well. It causes it to detach. Detaching it called this honeybee. Um, that's honeybee for me formation that you have. See that you see here. All right, so embrittlement. Right. Embrittlement is happen to acetate cellulose and nitrate cellulose, actually. What happened is the same, okay? Long polymers, right? These long polymers of cellulose, you have high groups of acetate or nitrate. It detach, it's forming whether it's nitric acid or acetic acid. It starts to attack the long polymers, and it will not attack only the long polymers, but it will start to attack the gelatin layer, actually. And we call that base or support to be very brittle and very weak. It's because fibers or the polymers of cellulose are now shorter than before. Well, shrinkage have the same, actually, but it were like in different shapes. If you can see here, this is like a normal form. This is before shrinkage and after shrinkage, actually. And this happened actually, like the delamination, it happened to both acetate cellulose and nitrate cellulose, to be very specific. And it happens because the difference to shrinkage between the base and the gelatin layers. Both the gelatin layer or the emulsion layer with the gelatin layer that hold the image and the anti-curling layer. Okay, so distortion have the same, right? Okay, so distortion having acetate cellulose and acetate nitrate cellulose. Okay, so dye fade. Dye fade, it happens to only color color films. Well, if you remember that it has dyes, several gelatin layers in the top of the base, all right? Uh, the most amazing thing in this dye fade and dyes are fading in both light and dark. So you can start storing your collection of color film in a dark place, and you just say to yourself, wow, it is safe and stuff, blah 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 blah, and just end up the dyes are fading. What happened is, in the presence of high temperature and moisture, the detaching of nitro groups and acetal groups from the cellulose, it start to forming acids, right? So these acids started to lowering the pH of the gelatin layer, which contains the dyes. This will improve or fish like help these dyes to start to fade. So it's not only the light that makes your dye fade. So next time when you store your color firms, you have to take in consideration this, right? Oh, anti-halation backing color retriever. Remember when I told you that anti-color layer, they add something called anti-halation dyes? Here it is. Uh, anti-halation dyes, it happen in acetic acids. Okay, so when you see an anti-halation backing color retriever, it is definitely an acetic acid because acid cellulose acetate film, because the acetic acid is catalyzed and starts helping these dyes to retrieve actually, and it start forming this blue color. Remember, I did the same like dye fading. Okay, so we will start with silver fading. Silver fading, actually, it happens when, remember when I told you the same acetyl group and nitric group, they attach from cellulose polymers. Okay, they start to form an oxidizers before they start forming strong oxidizers. They start forming acids, right? So these oxidizers and these acids, they start to attack the gelatin. Actually, it causes it to be weaker, and it start attacking the silver, corroding the silver itself, and start fading the silver. So to explain this, actually, how the silver fade. Okay, you have an oxidizer. Okay, inside oxidizer, you have the silver inside the gelatin layer. You have an oxidizer. That oxidizer, it oxidizes the silver particles. It oxidizes it into silver ions. Silver ions are not stable, right? It will start to migrate, start to moving through the gelatin layer. When it reduced back into silver, it reduced back into a silver particle, but it's smaller than first. So when it's silver particles, when it's bigger, it is darker. When it's smaller, it is less dark, which is fading. So it starts fading. It's because of the silver particles are smaller than first. Uh, Gelatin decomposition, as I mentioned before, right? That the nitric acid, right? It start to detach from the polymers and forming nitric acid and start attacking the gelatin, uh, cause it to be very brittle. And as you can see, sometimes it's not achievable, something like that. When you see something like that, it's not achievable because actually in this area, it is start to be sticky. It stick to each other, and it's very, 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 very difficult to detach from each other. Okay, Platysar oxidation. Platysar oxidation happen only in acetic and cellulose acetate films. It happens when the acetic acid that forms, acetic acid which has a vinegar syndrome, forms. Okay. Uh, in the negative or in the base, it start attacking the base because the base are more durable than before. So in the presence of heat, start in the weak point, as you can see, it's dots. Okay. So plus desire, okay, it's triphenyl phosphate, something like triphenyl phosphate, and other pesticides. They use it to enhance the flexibility of the film. So what happened is this plasticized and the weak point of the base, they start to migrate, forming these white dots. Actually, sometimes when it's dissolved because it's a plasticized, when it's dissolved, it can be back, right? So silver mirroring happens on the silver. Silver is an image. As you can see, it can cover your photograph. By the way, you can treat this, right? So silver mirroring happen when an oxidize a silver ions, a silver particles. Silver particles turns to silver ions. Silver ions start to migrate to the surface of the gelatin silver and interact with hydrogen sulfide, forming silver sulfide, which is the silver mirror. It can be removed, by the way. Right, so radix blemishes, the same corrosion of silver can be seen as yellow or red spots, like you see here. And most of fungus, of course, you have the gelatin, so it's like the food for these ones. And it can be seen in this spores can be seen in this formation. So after we have learned about the deterioration of our firms, some deterioration aspects about our firm, what is the ideal environment parameters to store your collection? All right, so uh, remember when I told you temperature, relative humidity, and pollutants. So relative humidity and temperature are very essential because, for example, the temperature, when it increased by 5%, is double the rate of deterioration. For example, if you have your farm will be deteriorate in 1 year and 20 degrees. If you increase the temperature by 5 degrees, it will deteriorate in 6 months. So it doubles the rate of deterioration. Relative humidity is the amount of water, and when it's not okay if it's increase, it will interact with the acetyl group or nitric group forming nitric acid or acetic acid. Right. So the ideal relative humidity is between something between 30 and 55%, not less, not more. Right. And the best way to store your film of collection is free storing. For my opinion, it's free storing because free storing it will hold the deterioration because deterioration is a chemical reaction. If you freeze it, it will not um, when you freeze it, the chemical reaction it will start to slow, then it will stop. Right? So we will talk. I don't know, but I will give you an example of one of the projects that I've been involved in. It happened in Cairo project, right? I had a collection of films in the Egyptian Ministry of Antiques, right? This is a collection that I've been working in. It contains like something between 10,000 to 50 to 11,000 firms. I'm not quite sure about the numbers. Actually, when I started working in 2020. It was a pandemic era, right? So when you can see it was stored something like that, it was in these boxes that has a glassine envelope. I will show you the glassine envelopes, something like that. These on the glassine envelope, inside the glassine envelope are the negative actually. So this is how it looks like. Were very sticky to each other. Some has no glassine envelopes actually, and it's the same. They were stick to each other also, right? And this is how it looks like, actually. So, Brittleman, gelatin decomposition, as you can see, uh, yeah, something like that. If you seen the one in the bright, this is nitrate, for example. This is the amber, like yellow amber color that I've been telling you. What I've seen that this is nitrate. There's no need for identification. And this is channeling. This is channeling, actually. This is not nitrate cellulose, as cellulose nitrate. It's an acetate cellulose. 100% sure. Okay, so what I did, I started detach the glassine, the envelopes between from each other, all right? And then I started to detach the negatives from the envelopes itself. They were very sticky. It takes a lot of time, actually. And I left it something like that. All right. It's because it were very sticky. I just wanted to be, hardening a little bit, actually. It's because it's sticky. It's because the plasticine, it's because of the heat, the plasticine have melted and have done that. Acetate cellulose, it's not sticky. Usually it's not sticky. That's why when I told you stickiness, it's not like a very, very accurate sign of nitrate cellulose. Well, for the good condition one, I started to brushing it. Okay, then it comes to the housing. I used the four flap enclosures to house the negatives. Actually, these four flap enclosures are folding together. Okay, this is an enclosure that I've created for the high deteriorated, something that's called the channeling one, that acetate cellulose negative. Okay, that you can hold it without have to be touched, and actually in the edges it's open so it can breathe in and breathe out. Uh, well, the four flap enclosure then have been put in boxes. Okay, so I have to mention that all the materials that have been used in any photographic work, it has to pass a PAT, which is a photography activity test. All of this has passed a photography activity test. Right, so after the boxes have been closed, it comes as the storage area, which what I used this technique was using the anti-moisture technique, because when you freeze storing them, it's also free storing. Well, if you're storing it, it has some procedures you have to follow. One of the procedures, you have to use an anti-moisture bag or case, all right, which were not available because of the pandemic. There were no shedding all around the world. All the planes were on the ground, actually. So I invented this technique using only the aluminum foil that you have in your kitchen, and you fold it in a certain way. Using this, it will not only prevent the moisture from entering into to the boxes itself. No, when you take it out from the freezing storing, you have to do something called temperature accumulation. Temperature accumulation, you have to gradually increase the temperature so you will not hit the dew point. So you will end up with depositing water drops on your object because of the dew point, because you crossed the dew point. Dew point, for your information, is the point of when the air is very full of water. They start to condensate. Start to condensate water. That's why you have your beer, when you have a beer or you have Coca-Cola out of in a summer day, out of the freezer, it start to condensate water, double fat. So using this not only you don't have to do the temperature accumulation, actually, you can take it out directly to your temperature room and you start noticing no condensation of water. So I will just leave you with one of my work here, right? So you will see how is it possible to treat a very deteriorated film. If you have seen this kind of films in your collection, do not throw it away. We can restore them. Okay, so let's start, right? Hope you enjoyed the video. Okay, so this is the end of my lecture today. Okay, no, not again. Okay, so this is the end of my lecture for today. So thank you so much for listening, and I hope you enjoyed the sound effects that I've added to the video. Okay, so here to Ellen, I'm ready to receive some question if you have some. I will
Thanks
stop
very much.
sharing. Yeah, I will stop
Um,
sharing my screen here.
Perfect. Thank you. That was
Okay,
amazing. It was so interesting for me as well.
thank
Personally,
you.
I think you're just getting a lot of thank yous at the moment, but I might use the chance to ask you a question. So
Yeah.
in the National Museum of Ireland, where I work as a paper conservator, we freeze all our objects coming in as part of IPM.
Mm,
But because I'm a paper conservator, not a photographic conservator, I'm really,
mm.
really afraid of freezing photographs. So
What kind of
we
photographs do you use?
it's
What kind
mainly
of
mainly silver
photographs?
gelatin coming in. Mainly
Oh,
silver
so
gelatin, but
okay,
mainly as
what
well modern. So it's
silver? Okay, silver gelatin. What? Silver gelatin prints or silver gelatin negatives or
it's
silver
mainly silver
gelatin?
gelatin prints. And we have gotten a few negatives, which I'm even more afraid of because they're not on a paper
You
support.
freed you freed those?
No, we don't do we just
You
quarantine
do
them
not.
because we're
No, you do not freed those.
oh perfect. That's grand.
It's
Yeah.
very harmful for them to be
Yeah.
freed, by the way.
Yeah.
If you have glass plate negative, do not freeze them.
No. We
Also,
we don't freeze any of them. That's the way we should be doing it. Just quarantine.
exactly. But
Perfect.
if you
Thank
have
you.
a chromogen, if you have a chromogenic
Yeah.
prints, you have to freeze them.
Okay.
And films, of course.
Yeah. Perfect. Thanks very much. Thank you.
You're welcome.
You're just getting loads of thank yous. Thank you, amazing talk. Thank you, thank you, thank you,
You're
fascinating lecture.
welcome.
Loads and loads of thank yous.
Well,
Um,
questions? You
Perfect.
have that?
I'm just going to end the recording now. Um, so does anyone have any further questions for Mohammed? And remember, he has very kindly offered to have his lecture recorded, so we'll be able to share a copy of that with you if that's okay. Mohammed's agreed
Yeah,
to.
it's okay for
Yeah,
us to
yeah,
share
perfect.
knowledge. That's what we do.
Yeah, well, thanks so much, everyone. And I saw a few queries about, oh, another thank you. It's just mainly thank
Mm.
you.
Right, questions,
Um,
guys.
we had a few queries about certificates. I'm going to have to look into that with ICRI, and I might chat to
Mhm.
you a little bit about it, Mohammed, afterwards. Um, but apart from that, that might be the end, unless anyone has a question. I was just going to say that we have another lecture in this series from Iman Taha on the
Mhm.
22nd of August, which is a Friday, not a Saturday. Oh, um, sorry, we've gotten two questions just there.
Good
Sorry.
question. So,
Sorry.
I'm happy to read.
What type of photography did he say not to freeze? Thank you. Fascinating topic.
Okay, so basically, free storing, as I told you, the temperature is accelerates the deterioration because deterioration is a chemical reaction, actually. Because some kind of photographs, it's very harmful for them to be free storing, and some other one. That's why I told you it's very important to identify what kind of photographs do you have in your collection? For example, like Ellen said, silver gelatin DOB prints and silver gelatin DOB negatives. It cannot be freeze storing actually. You freeze something like chromogenic, which is color photography, chromogenic because it's dyes and dyes tend to fade, like what I explained. Dye fading and it fade also in dark, so free storing will help you keep your photographic collection from chromogenic prints safe. And what's like when you see them, you freeze storing